Now let us discuss another topic of Doppler effect. When a stationary shows and a moving observer, the observer moving toward the source and the source is at rest. The observer listen apparent the frequency of the sound which appear to the observer is increasing. We know that whenever the distance between the source and observer is decreasing, the frequency will increase. But this will be not a symmetrical one, because in that case, when the observer moving toward the stationary source, when you calculate the frequency, and when the source is moving toward the observer is at rest, both have the in both the cases the frequency will be different one. That's why Doppler effect in sound is not symmetrical. So we have some different formula, but the apparent frequency will be more than that of the original frequency. So now this is the case when both are at rest. This is stationary and this is also at rest at the beginning. So we know that in 1 second, suppose in 1 second, the source produces F4. F4 is the original frequency. We know that this is one wavelength. This is called one wavelength. Also called one wave. So suppose F4, this is the original frequency. Original frequency of the sound. By the definitions of frequency, we know that the number of wave travel in 1 second known as the frequency. Now in 1 second, suppose the observer receives, and both are at rest. The observer receives in 1 second f0, that is that values of frequency in 1 second. It means that the observer receiving f0 wave, yeah, that much of wavelength in 1 second. So in 1 second, all the wave pass through this ones. In 1 second, the wave traveling from the source to the observer and crossed in 1 second f0 frequency. These are the f0 waves in 1 second, which is passed through this which is the pass through the observer. I mean that the observer received f0 of waves in 1 second. Now when the observer is moving, now the observer is moving toward the stationary source. Now its velocity becomes VO. Now in 1 second, the observer moving from this point to this point. This is the after 1 second the position of the observer. This is the new position of the observer. The observer traverses a distance of f0 in 1 second. We know that velocity is equal to distance divided by time. If our time is become 1 second, it means that distance traveled by the observer in 1 second is equal to d. So that much of distance traveled by the observer in 1 second. In 1 second, the waves which contained in the mediums in these regions, the observer receives these waves in 1 second. These waves plus some extra waves which is residing between this point and this point. These will be some extra wave with the observer received this one. So therefore the apparent frequency will be this is known as the apparent frequency. Is equal to original frequency plus in 1 second the distance traveled by the observer is equal to this one. Observer had traveled a distance in 1 second f0, and how many waves contain this one? If you divide by this by the wavelength, we will get the frequencies which we get the wavelength or the number of waves which contained in the distance of v0. That value comes out v0 divided by original wavelength. And we also uh, velocity is equal to original wavelength into original frequency of the sound. If I put the value of lambda naught from here, if I calculate the value of lambda naught from here, lambda naught comes out V divided by F naught. If you place these values here, so we will get apparent frequency which is observed, which is listened by the observer, would be V naught divided by D upon F naught. After simplification, it comes out F naught B naught upon V into F naught. If I taken out F naught outside this one, and V naught divided by V outside become F naught, this value comes out. After taking the LCM, make the LCMs V plus V naught observer velocity divided by air velocity, sound velocity in air multiplied of this one. So this is our apparent frequency. This is the apparent frequency. Since we know that numerator of F naught is more than that of the denominator. In the denominator we have only V, and in the numerator we have V plus V naught. So this value is greater than this one. That's why the factors of F naught is more than 1. So from here we say that F apparent is greater than that of the original frequency. So this is the another case of the Doppler effect. Very important effects. We can use many natural things in nature, and that's why when the source is moving, when this is moving source, no, this is the stationary source and this is the moving observer. Whenever the moving observer coming toward the stationary sources, or a moving source going toward the stationary observers, in both the cases we have increased velocity, increased frequency. That frequency will be different in the earlier case and this case. So this is our final formula for the apparent frequency. Observer at rest at the beginning. In the second case, t is equal to 1 second. The observer moved from here to here.